Hi there. So today I'm going to talk to you about authistry, or the art of web authentication. A little bit about myself. My name is Maida. I am a Google developer expert. I organize a meetup in Ann Arbor, Michigan. And I'm also the head of developer relations at Auth0. And Auth0 is a company that provides something that we call identity as a service. Essentially, this is a cloud platform that helps you to authenticate your users and protect your data and your APIs. Now, this talk is about authentication, but I want you to know that companies like Auth0 exist to deal with all of the complexity of authentication and authorization, essentially so that you don't really have to. Now, when people take on an authentication project or an authentication feature, they're usually aware that this is a big thing to attempt, and they're quite rightfully concerned about what could potentially go wrong. Now, auth standards are actually very clearly defined, but they are challenging to get right. So here's the thing. When you're going to go at authentication, you might start with a vague idea, like maybe I should search for auth on Google, and then you can get to the full picture. You can get to this work of art by doing the rest of the auth stuff, by essentially doing something like using an identity as a service solution like Auth0, and it really is that easy. It really can be that easy. But since you're here listening to my talk today, I'm basically going to go back a little bit and show you more of the steps in between that vague idea and the finished product. And you don't need to be an expert in all of this to get to that beautiful end result. But again, since you're here, I'm assuming that you're interested in learning a little bit more. So I'm going to give you some information that helps you sort of take you on a journey from that beginning vague idea to that end product. Now, I'm going to start with an introduction to some commonly used open standards. I'm going to go through this in hopefully an approachable way. I'm going to provide you with some foundational knowledge on standards-based authentication, and then I'm going to show you how this applies to JavaScript clients. Now let's start with a little bit of terminology. So I work in identity, and when people sort of ask, what do you do as a job? If I say I work in identity, though, a lot of people would assume something like maybe I work for the Secretary of State issuing driver's licenses, or maybe I help people deal with identity theft, credit card fraud, something like that. And this isn't the case. I actually work in digital identity. And when we talk about digital identity, what we're referring to is essentially a set of attributes that define an individual user in the context of a function that's delivered by a particular application. Now, that's sort of a lot of words. What does that really mean? Let's say, for example, that you are an online shoe retailer. Your company or your service provides a site where people can go online and buy and order shoes and have them shipped to their house. Now, the digital identity of the users of your application might include things like their credit card number, their shipping address, maybe their purchase history, the list of the last 10 pairs of shoes that they've bought. So another term that we come across is authentication. And when we say authentication, what do we mean by this? What does this actually mean? Well, authentication in sort of a broad sense refers to the process of verifying that the user is who they say they are. And once we have a knowledge of who the user is, we come to this other concept called authorization. And authorization is really about granting or denying rights to access resources. And when we're talking about the concept of authorization as relating to building websites and protected web apps, this often leads us down a road to a standard called OAuth 2.0. But I want to clarify a few things here because I want people to understand the purpose of the OAuth standards. And in order to do that, we kind of have to do a little bit of a history lesson and go back to the land of the web before OAuth existed. Now, OAuth 1.0 was established in December of 2007. And before then, if we wanted to access third-party resources in one application from another application, it might look something a little bit more like this. So let's say that you use a service called Hire Me, and you are a user, And then you also use a web app called MyCal app to manage your calendar. And let's say that Hire Me as a service wants to add an event to your MyCal. Now, in order to do this before OAuth, it would look like this. Hire Me in the browser would prompt you, the user, for your MyCal app credentials, your username and password for MyCal. Now, you would provide these credentials to Hire Me, and then Hire Me would use your credentials to access the MyCal API. Once it's got access to the API, then it can create calendar events using that access that you provided by giving Hire Me your MyCal credentials. Now, I hope you can see a few issues with this approach. First of all, sharing credentials is just a bad idea. The thing is, this approach relied on sharing a user's personal information from one application with a completely different application. And this is just in general not a good idea. Now, if Hire Me doesn't do their due diligence, they really have less at stake than MyCal. So if they were to leak your MyCal credentials, for example, then they might get some bad press, people might write some negative articles about them, but it's not going to be a catastrophic event for them the way that it would be catastrophic for MyCal, because they're the entity that actually had their information leaked. Now, Hire Me in this scenario also has way too much access to the MyCal API. Hire Me has as much access as you, the user of MyCal, has. So anything that you can do, Hire Me can use your credentials to do that also. So they could delete events off your calendar, they could read all of your settings, they could change your settings, they could read your entire calendar, all the other events on it, etc. So this really was not a good scenario to be in. And this is essentially why OAuth came about. Now, I'm going to specifically talk about OAuth 2.0. And OAuth 2.0 is an open standard for performing what we call delegated authorization. Using OAuth, MyCal can actually delegate authorization to Hire Me to provide it with limited access to the MyCal API without incurring the risks of sharing credentials. And it does this using something called an authorization server. Now, an authorization server is really kind of just a fancy word for a set of endpoints whose purpose is to interact with the user and to issue tokens. So if we come back to our scenario again with MyCal and Hire Me, only now we're going to be using OAuth 2, let's say that MyCal has this authorization server, and we're going to assume that Hire Me has already registered as a known client with MyCal. So essentially, MyCal is already aware of the fact that Hire Me may be asking for delegated authorization to use its APIs in the future. Now let's say that you, as a user, are logged in with Hire Me already, and Hire Me wants to set calendar event on your MyCal. Now what's going to happen next is the browser is going to perform a GET request to send an authorization request to the MyCal authorization server. It's going to say, hey, I'm Hire Me, and I would like to request authorization. MyCal's authorization server is then going to prompt the user in the browser to log in with MyCal using their MyCal credentials if they're not already logged in. The user is then going to authenticate with MyCal, and then the MyCal authorization server is going to prompt the user in the browser for their consent to allow Hire Me to access the MyCal APIs in order to do one specific thing, to add an event on the user's behalf, and not do any more than that. Now, if the user agrees, they say, yes, this is okay, then the MyCal authorization server is going to send what we call an authorization code to Hire Me using the browser, and Hire Me is then going to send back the code and its own app credentials so that it can receive an access token. At that point, MyCal knows that is going to authorize Hire Me to access its APIs through the use of this access token, and Hire Me can use the access token to call the APIs only within the scope of permissions that were provided by the user. So when we said, hey user, is it okay if Hire Me adds an event to your calendar, and the user said yes, that access token only allows the application Hire Me to add the event to the calendar and not do any more than that. So now at this point, Hire Me can set calendar events for the user using the MyCal API. And nothing insidious is happening now. MyCal is asking the user to log in with MyCal. HireMe is not asking for the user's MyCal credentials, and HireMe can only create events, not read all events or change settings or do anything like that. And so we have all of our issues with sharing credentials and too much access. Essentially, they're no longer a problem. Now, the thing that happened, though, was that applications, when they started using OAuth, they wanted to do more than just call APIs. They wanted to have the ability to sign users in with accounts that lived in other systems. So for example, maybe HireMe wants a MyCal user to be able to log into HireMe using their MyCal account, even if they don't have a HireMe account. Now, this is an important distinction. OAuth 2 is for delegated access. It's not an authentication protocol. So we get some issues if we try to use it like one. For example, if HireMe does something like try to use this access token that it received for the MyCal API, and it assumes that because I have this access token and it calls the API successfully, then that means the user's authenticated, then we run into some issues with this. Because somebody could have stolen this token. The token could be from a completely different user. It could have been obtained from another client that's not HireMe and then injected into HireMe. And this is called the confused deputy problem. HireMe really doesn't know where this token came from. It doesn't know who it was issued for. It just knows it can use it to access the MyCal API resources. Now, if we think back to what we said about what authentication is, it's about verifying that the user is who they say they are. And HireMe just can't know this from this access token. So in order to address this, we really need to formalize authentication on top of OAuth. What would this look like? And this is how the OpenID Connect specification came about. Now, OIDC is an identity layer on top of OAuth 2 that tells us how to authenticate users using an authorization server. So again, to be super clear, OAuth 2 is about delegated authorization. OIDC is the standard for authentication on top of OAuth 2. So if we come back to our authorization server, we know that it issues tokens. And for authentication with OIDC, we are going to do this with a certain type of token called an ID token. Now, let's say we have our authorization server, and this authorization server is capable of issuing ID tokens similarly to the way that it issues access tokens. However, ID tokens are meant for the client, so they're a fixed format that clients are able to parse and validate in order to extract identity information from the token and therefore be able to establish the identity of the user and authenticate them. So OpenID Connect extends OAuth 2 to show us how to issue ID tokens with an authorization server. Now, as I mentioned, the OIDC spec declares a fixed format for ID tokens, and this fixed format is the JSON Web Token format. JSON Web Tokens look like this. They're 3 string segments concatenated with periods, and this first segment is called the header segment, and this is a JSON object that contains the signing algorithm and the token type, and then it's base64 URL encoded so that it's URL safe. The second segment is called the payload segment, and this contains data claims. It's another JSON object, and it includes statements about the user and the authentication event. And again, like the header segment, the payload segment is also base64 URL encoded. Now, the last segment is called the crypto segment, and this is a signature. JSON Web Tokens are signed so that they can't be modified in transit. So when an authorization server issues an ID token, it's going to sign it using a key. And then when the client receives that ID token, it's going to validate that signature using a key. And if we use asymmetric signing, then different keys are used to sign and validate. And if this is the case, then only the authorization server holds the ability to sign new tokens. Now, as per their moniker, ID tokens provide identity information. So if we come back to the payload segment and those data claims, this is the JSON object with statements about the user and about the authentication event. And if we take a closer look at the authentication claims, for example, we might get some things that look like this. First of all, we have an issuer, and this is your authorization server. It's the entity that issued the token in the first place. We also have what's called an audience, and this is essentially going to be the client ID of the application that the token was issued for. So it's the intended recipient of this token. We also will have timestamps for when the token expires and when it was issued. And then we might have something called a nonce. And a nonce is it's a cryptographic random string that binds the client to the ID token that it receives. So the nonce is placed in the authorization request that the application sends to the authorization server. It says, "Hi, I'm an application. I want an ID token." And it includes the nonce in this request. Then the authorization server, when it issues the token, it takes that nonce and it puts it inside the token in a claim. That way, when the application decodes the token, it's going to check to verify that the nonce that's in the claim in the token matches the same nonce that is sent in its authorization request to the authorization server. And what this does is it protects us against something called token injection. And essentially, this is when tokens are coming from somewhere other than the authorization server. So, in addition to validating the signature, the client application, when it receives the token, is going to want to verify the authentication claims as well, like making sure that the issuer is the authorization server it requested the token from, making sure that the audience is correct, the token was issued for the application that it is identifying itself as, making sure that it's within a valid time window with timestamps, and of course checking the nonce, as I just mentioned before. Now, claims can also contain statements about the end user because they're in the context of being an ID token, they identify the user. So here are some standard claims that we can ask the authorization server to include when it issues an ID token. We could have information like this. Probably the most significant one is the subject. This is a unique user identifier, so you can think of it kind of as the user ID. Then we can also ask for other profile claims like address, nickname, email, is the email verified, website, etc., so on and so forth. So what have we learned so far? If we come back to our idea of sort of going from a couple of circles to a beautiful piece of art, then we have talked about the purpose of OAuth and how it came about and the difference between OAuth and authentication with OpenID Connect. We talked about authorization servers, ID tokens, the JSON Web Token format. We talked about ID token claims, and now essentially I want to pull all of this together. So in serverless scenarios, we often use the JAMstack. And the JAMstack is composed essentially of JavaScript on the client, APIs for providing data resources, and markup. So these things all together are the JAMstack, which leads us to how do we authenticate specifically for JavaScript clients. And when we use tokens for authentication in JavaScript, it looks something like this. First of all, we have the browser. And then when the user navigates to our site, the code is downloaded to the browser. Then we're going to call APIs for data resources. And we have our authorization server for authentication and authorization. Now, when a user wants to log in, we're going to make an authorization request, and the authorization server is going to verify the credentials and issue tokens. The tokens are then sent to the browser, and then the authorization server sets a cookie in the browser for the authorization server's domain. Now, this represents the user's session with the authorization server itself. The ID token is going to be parsed and validated in the client, and at this point the user can be considered authenticated. Now, we make HTTP requests to the API, and when we do that, we can place the access token in the authorization header of those requests, and the API is going to verify this token using middleware, and then if everything is good, it's going to return data back to the browser. Now, if the page is refreshed or reloaded, then the JavaScript has to be re-downloaded, and we lose everything that may have been in JavaScript memory and app memory. So if we don't have user info or tokens anymore, we can actually use this cookie that was set by the authorization server in order to check the session. So if the authorization server session is still valid, we use an iframe and the authorization server cookie And we can send a request to the authorization server silently without ever prompting the user to enter their username and password again, and request new tokens without user interaction. Now, the next thing I want to talk about is guidance for the use of tokens in the browser. Now, in 2012, when the OAuth 2 spec was adopted, JAMstack sites, JavaScript sites, and single-page applications, they just weren't mainstream yet. They existed, but they weren't mainstream. They didn't reach a critical mass until fairly recently. So if we make a request to the authorization server, what's going to happen is the same endpoint that receives that authorization request returns tokens to the browser in the URL hash fragment. Now, this is what we've been doing for a long time, as sort of dictated as the best practice for JavaScript applications that run in the browser, but there's security risks here, especially for access tokens, which grant API access. Remember the issue that we had with the confused deputy. So if we have tokens in the URL, then they're vulnerable in a number of different places. For example, they're vulnerable in the redirect URI, which can be used to redirect the token to somewhere maybe it's not supposed to go. It's accessible in the browser history, which is an API that is freely available to any JavaScript running on the page. It's also accessible in the refer header, which could potentially cause problems if a malicious page is somehow requested right after an authentication event. And finally, the client doesn't automatically know if this token was injected maliciously from somewhere else. Now, we talked about doing things with the nonce, etc. So keep in mind that authorization servers and developers work pretty hard to mitigate these security risks. There's no new threats to this approach, and I want to be super clear, there's no new threats to this approach. These same mitigations will continue to work, but now that JavaScript is basically eating the modern web, it's just time to recommend new best practices. So in early 2019, there was new OAuth 2 best current practices drafted for browser-based applications. Essentially, the approach that is being recommended now is the same approach that's used in mobile applications, which are also public clients. So if you have your authorization server and your application running in the browser, what we're going to do now is the recommendation is to exchange a code for a token. And it looks something like this. In the browser, on the client, we're going to create a random string, and this string is called a code verifier. Now, using a hashing method called the code challenge method, we're going to compute another string from that verifier. And then when the user comes along, we're going to send an authorization request, and we're going to send the code challenge method, that hashing method, and the code challenge to the authorization server's authorization endpoint. The authorization server is going to take this information and it's going to generate a code. And the code's then going to be sent to the browser and it's going to be received in a URL query string. Now, interception of this code isn't dangerous, so it's okay to put it in the URL. The code by itself doesn't grant us access to anything. If someone were to steal it and try and send it somewhere, it wouldn't really help them. It wouldn't get them anywhere. Because once we have that code, then we're going to send the code and the code verifier to the authorization server's token endpoint. And at this point, the authorization server is going to calculate the code challenge using the code challenge method, and it's going to then compare the calculated code challenge to the challenge that was sent by the client earlier on in this process. If these two challenges match, the one that was sent by the client and the one that the authorization server calculated from the code verifier, then tokens can be issued and they'll be delivered to the browser in a JSON object. Now, at this point, all of the mitigations that we had to do for security risks that are present if we put the token in the URL are essentially no longer needed. But this looks like a lot of work, right? We have this code, we've got this code verifier, we have a hashing method, we have to create another string from the verifier with the hashing method, and all of this sort of back and forth with the authorization server. It looks like a lot. But the great thing is that SDKs can really do a lot of this work for you. So essentially, you can use an SDK provided by an authorization server and plug that into your application and basically offload all of that to the experts. So these new best practices, what does this mean for you as a developer? Well, if you're building a brand new project, you have sort of a greenfield, I would strongly recommend that you try this new approach. It is more secure, it requires fewer mitigations, and many authorization servers do already support it. However, if you have existing projects and you're sort of looking to see if you should take action as a result of these new best practices, I want to reiterate that there's no new threats. The flow that we've been using for the last 7 years, it's not at any more risk now than it has been for those 7 years. There are innumerable JavaScript applications and sites out there on the web in production operating that use that original approach, so I would really encourage you to take a pragmatic view if you have existing projects. Assess your needs, and then make the choice that works best for your project, your team, your company, clients that you may be working with. Keep in mind, though, that if you do use an SDK provided by an authorization server and you're already using an authorization server, it can be pretty low impact to make this change, but make sure that you assess the circumstances that you're in before you make a decision. So essentially now, we've put everything together that we talked about so far, and we've covered client-side JavaScript authentication using tokens. But I want you to remember, this still really only has to be a two-step process. Now you've leveled up, we've gone through sort of the steps in between to draw the owl, but you can use an identity service to just get started today. And one such service that you could potentially use is called Auth0. This is an identity as a service solution. And Auth0 provides a JavaScript SDK, which does handle the new best current practices for JavaScript sites and apps with authentication. And we also provide quick start tutorials with sample code that help you to quickly and easily implement the new best practices in JavaScript in your sites and applications. Now, in addition, our principal architect, Sandrino Mattia, wrote this fantastic blog article that explains authentication for different architectures. And the article includes a couple of different flavors of serverless deployment with Next.js. So I would strongly encourage you to check out that blog article, and you can find it at the link that is on this slide. So I hope that today I've been able to demystify a lot of the standards and the basics of authentication and authorization on the web. And keep in mind, there is a lot more than this. There's quite a lot more. So you can grab these slides at the bit.ly link here. And I would also encourage you to check out this Learn Identity free video course that's part of the Auth0 documentation. If I've sort of whetted your appetite with this talk to learn a lot more about identity and authentication, authorization, the different flows for different types of applications and different architectures, then this course, with this Learn Identity course that is provided on Auth0, is actually the same training that Auth0 employees receive when they're onboarded to the job. So if you want to learn about identity the way that Auth0 employees do, then please check it out. You can just go to the link and start right away. Now, I would love for you to connect with me on Twitter if you have any questions or just want to chat, or if you want to learn more about Auth0, or if you want some help with your Auth0 integration. Twitter is where I mostly talk about identity, I talk about developer relations, I talk about tech, and occasionally, once in a while, I do share little animated doodles like this one. So I really appreciate your time today. Thank you very much.